Okay, good morning. Doing this video to go over our 9A notes on exponential functions. And this is really kind of a cool unit because exponential functions are used a lot with regards to, money and finance and growth and stuff like that. So kind of a cool unit where we're really able to apply a bunch of stuff. So I want you guys to think about these scenarios here, okay? Um, think about it, see if you can figure out sort of a rule or a pattern for this. And then um, come up with a pattern for X days, and then maybe create um, a an equation for this scenario. Okay, so take a few minutes and try to figure those out. You can pause the video if you need to, and once you figure it out, I'm going to go down and go over the nuts and bolts of the exponential functions thing right here. Okay, the parent the parent exponential function is y equals 2x, 2 to the x power, I should say. So that's the parent exponential function. However, um, I don't like the way it's written like that. I really like to write it as y equals 1 times 2 to the x power, with our a value being equal to 1. Okay. So y equals 2 to the x power is really y equals 1 times 2 to the x power, which, if you haven't noticed already, would be our perfect model for the scenario that I put up above for you guys. Okay, because the format for the exponential function um, is y equals ab to the x power. So that's the format. This is the parent function, y equals 2 to the x power, but this is sort of the format that I want to look at. Okay, just the same way that with a linear function, you know the parent linear function was y equals x, but the format that we kind of looked at the most is y equals mx plus b, where we had our slope as m and our b is our y-intercept, and we were able to sort of graph it. Okay, so the format I want to look at for these exponential functions is sort of like that: y equals a times b to the x power. Okay, now when we have this y equals a times b to the x power, okay, um, our a is going to represent how much of something that we have to start with, okay, which is sort of our starting amount. Okay, with money, a lot of times that's called the principal. Okay, so it's the amount that you're starting with. Okay, our B is going to represent our rate of growth, which we're going to call a growth factor. Okay, so the B is sort of called the growth factor, and X represents the number of repetitions, basically. Okay, X represents our number of repetitions. So take a moment, copy that down, pause the video if you need to. I'm going to go back up to the top real quick, and we'll talk about sort of how this thing works here. Okay. So if we have $1 today, okay, so $1 today, that's going to really make our A equal to 1. Okay. And then our money doubles every day. Okay, doubles, which means our growth rate is 2 because it multiplies by 2. So our B is equal to 2. Okay, so after 4 days, okay, it would be 1 times 2 to the fourth power. 5 days would be 1 times 2 to the fifth power. 8 days would be 1 times 2 to the eighth power. Okay, if our money doubles every day. For X days, it would be $1 times 2 to the X power. Okay, and the reason being for this is let me take a minute to break it down. So how much do we have after 4 days, right? So if we start off with $1 and the money doubles every day, what's really going to happen is we're going to multiply by 2, by 2, by 2, and by 2. So now, we start off with $1. After day 1, we have $2. Okay. Then after day 2, we have $4. So that $2 doubles. Okay. And then after day 3, we have $8. Okay. Then after day 4, go red here, we have $16 because whatever we have doubles every day. Okay. So we start at 1, it doubles to 2. Okay. Then we have 2, then it doubles the next day to 4. 4, then it doubles the next day to 8. 8 doubles the next day to 16. Okay. So seeing the colors here, we're going to double each time. That's why we're going to multiply by 2 every single day. Okay. And as we see, with our graph here in a minute, we're going to see how this thing really takes off. All right, so here's our parent function, f of x equals 2 to the x power. Here's a table of values, so you can go ahead and sketch this out. Find a domain, range, x and y intercepts, and any asymptotes. And then we'll sort of go from there. And down here, we have transformations, so we really don't need a video or any instruction for this. You can sketch these out. You can graph them on Desmos. You can make tables of values if you need to, or whatever case you may be. And we're just going to use our transformation rules that we've looked at all the way back since Unit 1. Okay. So that's that. And we'll get to some more application on this when we get to 9A Part 2 and we get to 9B. And from there, we will continue working through exponential functions. So that is it. Take care and come holler at me if you have any questions.